All right, here we go, guys. Now, I definitely want to start with number 6 because that's going to take me some time. It's a really good proof. So everybody, let's do that. Yeah, there's so much going on here. All right. So, first thing we were talking about here as I was looking at this is I always try to get a, in my head, try to figure out how to solve it before I start writing things down. So I'm trying to prove that WZ is congruent to X or QY, which means I'm going to need these two triangles to be congruent, the red and the green triangles to be congruent. All right, now, okay, so I need this congruent to the green triangle. Now, again, to me, that was kind of tricky because I can see YZ is congruent to itself, but that's all. That's all I know. All right, and I got to come up with some angles and I got to come up with some sides. Now, I did notice that W is the midpoint of XY and Q is the midpoint of XZ, correct? And XY is equal to XZ. So I knew then that QZ is congruent to WY. So I agree with that? Now, just to make sure, if I said this was 10 and this was 10, the midpoint would make that 5, that 5, that 5, and that 5, right? So that's how I know they're equal. Should everybody agree with that? I just showed 10 as just a visual so you could see, okay, I can see that. All right. Now, I either have to have a side or I have to have an angle. All right. And then, does everybody remember isosceles? What does isosceles triangle say? What? And if two sides are equal, then what else is true? The opposite, the base angles are equal. That's what isosceles says. Is everybody with me? So that means now, if that's isosceles, that means this angle right here is equal to this angle right there. And now I've proven the triangles are congruent. Does everybody agree with that? So again, honestly, I think that's the way you do proofs. All right, you do proofs by looking at it and saying, I need to solve them. I need to make them congruent. All right. Now, the hard part is we have to go list everything that we just said. All right. Now, to me, it was harder to prove that WY is congruent to QZ. All right, I think that was the hard part. So we're gonna go ahead and tackle that first. All right, so what I wanna do now is I'm gonna do the given. We're gonna paste the given in here. And we'll call that 1 and given. All right, so this work up here is what I was trying to do. I didn't realize how many steps this proof's gonna take. So again, I really like this proof. All right, so let's take a look at it. Now, we know that XY is congruent to XZ. And again, this is harder, so just follow along with me, and at some point you get lost, you just tell me. All right, first thing I'm trying to prove is that WY is congruent to QZ. All right, that's what I'm trying to prove. What? YZ. Yeah. Just that's coming. That's coming. No. Yeah, we can do that. But what I'm saying is, I'm trying to do the hard part first. All right, so let's do that. All right, so let me see if I can show you. All right, step number 2 now, and I really don't like this picture, so I'm gonna copy this picture and move it over because I want to blow up the proof. All right, so I'm gonna copy this right here. and then I'm going to paste it over here. Oh. All right, so I'm going to paste it over here so I can look at it better. All right. Now, here's what I want. All right, I want the fact that step number 2, I want that xw plus wy is equal to xy, and I want xq plus qz is equal to xz. And somebody tell me why that's true. No, 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 no. Yes, say it again. Yeah, that's the segment addition postulate. All right, that's segment addition postulate. Anybody have any problems with that? Now, do you agree here that these two things are equal, right? So I can say now xw plus wy is equal to xq plus qz. Is everybody okay with that? All right. Now, oh, that's step 3, and that's just a what? Someone? Good job, guys. That's a substitution. Now, remember what I'm telling you. You got to speak up right now if you're not seeing that. And somebody like saying, well, I don't see that. There's no way I can do that. Yes, you're right. Right now, I'm not asking you to do it all. I'm asking you to follow along and see the logic. That's all I'm asking you to do. All right? Anybody have any doubts about that so far? What? Right here, the highlighted yellow. Right? XY is the same as this. You agree with that? So I replaced it. And then XZ is the same as this. So I just put those two things equal to each other. Everybody good on that? All right. Now, traditionally, what we do is we just go step by step, and they usually flow pretty evenly or pretty nicely. But in this case, I thought to myself, well, I can't really do anything more here because I don't know that WY is equal to XW, but is that true? Is that true? Yeah, because why? Definition of midpoint. Thank you very much. All right, so now what I want to do is I want to come down and I want to say XW is congruent to WY, and then I'm just going to put a comma, and I'm going to say XQ is congruent to QZ. And Brady, tell me again. Definition of midpoint. All right. So now, step number 5. XW plus XW. Uh-oh, I don't want to do that. Sorry. I want to say WY plus WY is equal to QZ plus QZ. Why is that? That's a substitution. All right, now look what I did. I knew, based on our observation, what we said earlier, I needed to know these two things were congruent. Does everybody agree with that? So I could have exchanged out XW, but then I would end up with these right here. Do I want those two? No, I'm interested in XW or XWY, sorry, and QZ. Those are the two things that I'm interested in. What? Well, because this right here, this is changing to this. You with me? Mm-hmm. Now I can say that 2WY plus 2QZ, uh-oh, not plus. I'm sorry, guys. That's equal. 2WY is equal to 2QZ. Does everybody see that? Tell me. Okay, so watch. 1WY plus 1WY is 2WY. You see what I'm saying now? Right, right. And I always tell my kids that's just simplifying. Yes. Well, because I could, but that would be WY minus WY. They're not equals over here yet. You see what I'm saying? If there was a WY on the other side, I would do that. All right, now I've just proven what? WY is congruent to what? QZ. Is everybody okay with that? Well, and actually I should just do this, just to be annoying. WY is equal to QZ, and that's the what? Division property of equality. What? Because I'm trying to prove that WY is equal to QZ. Right? Yeah. And now I'm just going to be annoying, and we're going to say because they're equal, they are also what? They are congruent. So that's definition of congruent. All right. So now, Morty, tell me again, step 9 now is what? Yeah, now we can say YZ. We go into the easy stuff. YZ is congruent to YZ, and that's what? Reflexive. So now what I want to do is I want to come over here now, and I want to go ahead and label this right here. And then I'm going to do, oh, come on. And then I'm going to label this W, Y, Z, and I'm going to grab it and move it down. Move it right here, I guess. And then I'm going to grab the other one, make it blue. And then U, Z, Y. Now we're going to grab that. All right, now we have marked this is congruent to this, and we have this is congruent to this. Now, what is the other piece we needed? Angle what? So now we're going to say angle for number 10. Angle Y is congruent to what? Angle Z. And we can say that's definition of what? Isosceles. And isosceles, remember, just says if two sides are equal, then what? The base angles are equal. So we know that angle Y is congruent to angle Z. So now help me out. What's next? Yes, sir. Good job. Say that for me. Triangle WYZ is congruent to triangle what? QZY, because SAS. Thank you. And finally, step 12. We are amazing. WZ is congruent to QY because CPCTC. All right, that really is good. Really good. All right, and again, that's our 12-step proof. All right, again, that just takes a little bit of time. That's definitely a little bit harder. All right. So again, I'm just asking you not to, that's what I'm saying. There's no reason you can't memorize that. You have to just understand everything that we just did. I don't think that's too difficult for us, although it was harder than usual. All right. Now, does anybody need me to re-explain something on that? That's very, very good. If you can organize your thoughts to prove that, that's really good. All right. So, was that where we left off? Or do we have anything else before this? Nope. Okay, so here we go. Let's knock out the next one. Number 7. Hopefully this is a little bit easier. So angle B and angle D are right angles. So I'm going to write that. Angle B and angle D are right angles. And AD is parallel to BC. And we're trying to prove those triangles are congruent. So I've got the lower triangle and the upper triangle. Okay, I think this is pretty simple. So let's see who made quick, who did this quickly. So number 1 I've got given here. All right, Kenzie, tell me something. Yes, here we go. AC is congruent to AC, and that is Y, reflexive. So let's all do that. Come on, I did not think this was that hard. All right, so here we go. So I'm going to mark that. All right, someone else. Sam. Yeah, I like that. Number 3. Angle B is congruent to angle D because all right angles are congruent. All right, let's hear it from somebody else. William. I can't really say angle C, but you have to be more specific. BCA is congruent to angle BAC, and of course that is what? Alternate interior angles are congruent. I'm going to mark that here. 1, 2. All right, number 5. Come on, someone else jump in here. Just go around the room. Somebody, tell me. Be careful. Is it angle, side angle? It's all right. Yes, you can say side angle, angle. All right, but I always write angle, angle, side. It doesn't matter though. That's pretty simple, pretty straightforward. Hope you feel good about that. Nothing to it. Anybody have any issues? All right, how's my homeschool peeps? You guys all right? Kind of quiet. All right, let's everybody take a look at the next one. All right, D is the midpoint of AC and BB is perpendicular to AC. All right, here we go. Let's just grab it. All right, now come on, guys. I don't want the same people. If you haven't said something, your job is to speak up. I don't want to be annoying. All right, speak up if you haven't said something. All right, no, I'm not going to let you say given. All right, everybody's got that. All right, here we go. Ruffin, go. You haven't said anything. AD is congruent to DC, and that is definition of midpoint. AD is congruent to DC, definition of midpoint. Beautiful. All right, Morty, I haven't heard from you. Why? But we haven't said they're right angles yet. You have to say something first. You have to say something first. Mr. Varner.
Angle ABB is the right angle.
Yes. There. Yes, yes. Perpendicular lines form 4 right angles. That's what we have to say. So in my opinion, I think you should say angle ADB and angle BDC are right angles. And thank you very much for that. That is the definition of perpendicular. And now, Morty, you can say what? All right angles are congruent. All right, I'm happy with that. And now step number 5, someone different, someone different. Come on. Watson, tell me, what are we going to use now? I know, listen to what you said. You said angle, even though I know you didn't mean. I know. Segment, she's correct. BD is congruent to BD. Tell me again, Watson. Reflexive. All right, so I'm going to come up here and mark it. Okay, good job. Tell me. Congruent to triangle CBD. And we would say again, why? We are great. Side, angle, side. All right, I'm feeling pretty good. All right, my homeschool peeps, you got to do number 9. All right, now number 9, I think as I was typing this up, I think I accidentally left one piece out. So what am I supposed to say here? Yeah, just put this in right here. Angle N is congruent to angle what? P, and that's given. All right, I don't know why I didn't type that. What are we talking about? Well, that's, oh, LM. Yeah, that's another typo. Because it should be, we don't have to. Yeah, this one is my fault again, guys. Some of these book problems, they just type things and have no idea. So let's redo the proof. I want everyone to retype the proof. All right, so I'm adding a text box in here, and then we're gonna rewrite this. All right. Oh. Okay. Now I know what they did. All right. So we don't need to retype anything. I just didn't realize what they were doing here. In this one, they're just giving you the figure, right? And then I wasn't paying attention. This is what we're trying to prove, right? So the given is the what? The figure itself. All right. Based off of the figure, what can we conclude? All right. Now, again, I don't know why I wrote this so much slower, but. All right. So here we go. Here's what we're looking at. So now in that picture, step number 1 is, somebody tell me what number 1 is. Someone different. Simon, you got to tell me what's going on here in number 1. Right, angle N is congruent to angle P. Uh-oh. Good, thank you. Segment NM is congruent to PQ. All right, and of course that's given. All right, I forgot my homeschool peeps. All right, who's up? Homeschool peeps. Someone volunteer. I need something. Step number 2. Who's up?
I'll go.
I'll go. Good. Lorenzo, tell me.
Oh, no, it's Aiden.
Oh, Aiden, sorry.
Zayden.
Sorry, I'm blind. I got mask and everything on. Sorry. Go.
You're fine.
It's getting old, so go.
ML is congruent to LQ, and that's the
I don't think so. I don't think you can just look at this right here, buddy, and say those are congruent. All right? I don't think so.
Mm-hmm.
Someone else, step in. Homeschool guys, what's true?
Olga, could angle NML be congruent to PQL?
It
Because
eventually will, but there's no way for us to know that. Come on, someone else from homeschool. Jude, bail everybody out. Tell us why.
Could angle
What?
NLM be congruent to PLQ because they're vertical angles?
Yay, good job. You bailed out your homeschool peeps. All right, here we go. So we're going to say angle NLM is congruent to angle PLQ, and she is correct. Vertical angle theorem. So now let's mark our figure. All right, now someone else from homeschool, tell me why those triangles are congruent.
angle, side.
Who said that?
Me, Harris.
Me, thank you, me. So triangles are now congruent. All right, so now we have, say what triangles are congruent. Harris?
Triangle NLM is congruent to triangle PLQ.
Why is that?
Angle, side.
Thank you. And finally, last step, step four. Who's up for homeschool peeps? Come on, Lorenzo, someone.
I can go again.
All right, Harris, help him out.
It would be LM is congruent to LQ because of CPCTC.
You are amazing. There you have it, guys. I don't think that's that hard. Everybody's doing good? Any questions? Let's do this. I think it's kind of important that you guys try. All right, I don't want to just do them all. I think everything else now is reasonable. I looked at 10, that's definitely reasonable. I looked at 11, that's definitely reasonable. 12 is good. 13 is good. All right, I want you guys to do that for homework. All right, 10, 11, 12, 13. All right, do those for homework. I'm probably gonna do them myself, and then tomorrow we're just gonna see how good you did. All right, I don't wanna spend any time, all right, finishing that up. What? Yeah, 10, 11, 12, 13. That's kind of like your homework. All right. Now, find the measure of sides of triangle KPL and classify it. All right, so here we go. We're going to do the first one. All right, measure 5, -3. We're going to plot this. 1, 2, 3, 4, 5, -3. I'm going to change color. 5, -3. Oh, what am I doing? 1, 2, 3, 4, 5, -3. And then 3, 4. And then -1, 1. All right, that almost looks like what type of triangle? That almost looks isosceles, but we will find out. All right, now remember, one of the main things I want you to learn is that the distance formula is just what theorem? Yes, Pythagorean theorem, that's all it is. All right, easy. All right, so let's name this properly here. This would be K, this would be P, and this would be L. All right, so let's find a spot for LP is equal to PK is equal to and LK. Somebody tell me what LP is. How much from here to here? 3. How much from here to here? 4 because we remember our Pythagorean triples. You remember the Pythagorean triple? 3, 4, what? 5. 3, 4, 5. So I want everybody to write these down. 3, 4, 5 are Pythagorean triples. All right, they're just helpful if you can remember that. You don't have to do all the arithmetic. Then the other one that's common is 5, 12, 13, 8, 15, 17, and 7, 24, 25. Those are helpful if you remember them. All right, especially 3, 4, 5, and 5, 12, 13. Those are the most common. Now, does everybody see how this is 3 right here, and this is 4? So we could say 3 squared plus 4 squared, 9 plus 16, 25. Square root of 25 is what? Anybody have any problem with that? All right, that's just simple little math. All right, so I have LP is 5. All right, now let's figure out what LK is. So to figure out what LK is, I'm just going to draw this out here. And let's figure it would be from here all the way to here. How much is that? 4, and then I'm going here, which is how much? Anybody agree with that? That's 6. So now, what's 4 squared? What's 6 squared? 36 plus 16, 52. So that's the square root of 52, right? But that's not good enough for us because that's 2 radical 13. Everybody remember that's 2 radical 13? Because 52 is 4 times 13, right? And then the square root of 4 is 2. Anybody have any problems with that? So I've got over here, PK is 2 radical 13. That's what I said. Marty Pants. Yeah, very funny. All right, here we go. Let's try. Uh-oh. Wow, is that right? 2 here. And how much is that? Yeah, 2 and 7. That's the square root of what? Square root of what? Something like that. Yes, square root of 53. So are they close?
Yeah.
Yes, but they are not. So what is that called? Yeah, not isosceles. Brilliant. Go ahead, put that on the test, Samuel. If it's not isosceles, it is scalene. Thank you. Finally. Scalene is no sides are equal. Equilateral is all sides are equal. All right, that is scalene. All right, that was close, guys. That was close. All right. So homework, knockout number 2. All right. And you should be able to put 2 on the same graph. All right. You can do number 2 on the graph. Finding the angles there, that should be relatively easy. A little puzzle for you. All right. Equilateral triangle means all the sides are what? Equal. Let's see what else. If there's anything more difficult here. Nothing. Nothing. I want you to try to do 16. That's a good one. All right, now what I'm trying to tell you is I'm flipping through here trying to see if there's anything that difficult, and I'm looking a couple SAT, ACT questions. Nothing too bad. All right, I definitely do not think we're going to have time to do all this tomorrow. All right, so I think you should try to get through, let's say we should try to get through 15. I think that'll give me enough time tomorrow to get 16 through the rest of it, 32. All right, and I want to give you some time to do a few things on your own. While you guys are sitting here working on it, and we still have how much time? No, we get out at 05, right? Yeah, so he's right. We got about 20 minutes. So I think 20 minutes of good work right here. I'm going to do the problems with us, and then I'm just going to project them tomorrow, and you're going to say, help me if you made a mistake. All right? I don't want to just give you the answers. I want you to try them just like it was you're taking your quiz and you got to do some proofs. All right? You can evaluate yourself and see if you're learning something. All right? And then, like I said, your objective should try to be to get through 15. All right, try to get through 15. Now, if you are concerned about your grade at all, I'd try to do everything and make sure you can ask me any question tomorrow. All right, that's if you're concerned at all, that's what I would be doing. Try to do the whole thing. All right, homeschool peeps. What I'll do is, sorry about that. What I'll do is I will shut the class down, but I'll leave you guys. If you guys want to talk to each other about it, you can. Does that sound good, guys? All right, you guys have a good rest of the day, and we'll finish this thing up tomorrow. All right?
All
Take
right,
care,
thank you.
guys.